How many 4s can we get out of 5? Okay, hopefully you caught that you start there. How many? Just 1. Okay, 4 times 1 is 4. Subtract that and then, subtract that and then bring that down. Okay, how many 4s out of 16, everybody?
4.
4. 4 times 4 is 16. And then we get 0. We bring this down. And how many 4s in 8? 2. Okay. So this one was pretty simple. 4 times 2 is 8, so we can subtract that. And we have no remainder. Checking that. 142 times 4. 4 times 2 is 8. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. 568. I just made that one up out of my head, and I have no idea it would come out that even. Anyway, I guess I was thinking even today. Anyway, all right, I'm going to flip over to our slides because there are a few on there that we will warm up with. I just totally clicked out of everything. What did I do? That was weird. Okay. All right, let's do this.
The dog. Workout time.
Okay, hold on.
We need more cat pictures.
All right, let's do that one right there. Now, it's been a few days. Give yourself a sec. Look at it. Take a second. Think how we did that before. And you basically have 2 different parts to add. You've got whole numbers and you've got fractions. Guys, I need you to double check your answer. Because if you just add up the whole numbers and then you just add up the fractions, it looks like you already have this pretty little mixed number. Be careful that mixed number doesn't have an improper fraction inside of it. Okay? The fraction in that mixed number can't be improper. Okay? So what would we do here? Some of you went right to work. Some of you, there's a long pause, and that's okay. You're thinking. What do you think?
What I did first is I added the fraction pieces, and I got 6 thirds.
Okay.
And then I thought of it, and then I got 2 more holes out of that, and then I added it to the holes, and then I got 6 in all.
Okay, so you kind of did your fractions first. Did anybody else do the fraction pieces first? All right. I think a lot of people are used to doing the what first?
The whole number.
The whole numbers. The whole numbers. So, not that it wouldn't work that way. If we did the whole numbers first, what would you get? You get 4. And then when you do the fractions, what do you get?
6 thirds.
6 thirds. Can you leave it like that?
No.
Not at all. Okay, this is improper with a larger number on top, so we can't leave that there. We've got to turn this piece into a number bond, but 6 over 3 is equal to what? 2 wholes. So, because I could pull 3 thirds out of here twice, and then I don't have anything left. Well, if those are whole numbers, let's put them with the other whole numbers and put all that together. So that's 1, 2, and then 4 more would be, your final answer is 6, and there's no fraction pieces.
Instead of 6, I put 5.
Up here?
Yeah, on the whole on the whole number.
Oh.
On the answer.
Gotcha. So it threw off your answer, didn't it? Okay, let's do one more. Just so we don't get rusty. Down here at the bottom, you can erase your board. This one at the bottom, we really do this more than we realize, so we're still good at it. We've had lots of practice. All I want you to do is change it. If they say convert it to a mixed number, you know you're using that number bond and changing it to a mixed number. So 64 ninths, what would you get as a mixed number for that? Number bond. Most 9 ninths that you can pull out of there. This really is a pretty quick one, isn't it? You know your nines. Okay. How many 9 ninths can we pull out of there? Yeah. 7. 9 times 7 is what, everybody?
63.
63, so very close. So if I pull all 63 at one time so that I don't have to go 9 ninths, 9 ninths, all 7 times. If I pull them all out at one time, that equals that number 7. I could do them all separately and then go 1, 2, 3, 4, 5, 6, 7. But I'm pulling them all out at once, and that is 7. And then how many are left over? Just 1. So 7 and 1 ninth. Okay. All right, we don't want to lose those fraction skills because remember, we've entered the world of what? Decimals, and decimals and fractions are going to work very closely together. All right. So, this is day 2 of decimals. You can clear off your board. You can move it to the corner of your desk. Yeah, day 2 of decimals, and yesterday was refreshing in this. Whenever I usually start this module, hey guys, we're starting decimals. Y'all's eyes get about this big, and it's like, what? And you look fearful for the first half of the lesson.
Yes.
And then y'all, by the end, yesterday, this was not as bad as I thought it would be. This was easy.
The way it sounds.
Yeah, exactly. And
the way it sounds.
I even mentioned that to the second period, and they had the same look on their face. And then they had the same reaction you did at the end of class. So I hope you feel better about getting into this. We're going to keep going with it. Yesterday we used some visual things to help us see what decimals were. What did we have on our whiteboards? Oh, no. What did we have on our boards yesterday? Yeah.
A number line and a I forgot
What?
It's like don't raise your hand. It's a diagram.
Okay, that's what I'm thinking. Have it ready to spill out right when you know. All right, so he said it. Number line and a tape diagram. Okay. We had those on our board, but then we also did what? With that long thing. One more visual. Please put that in your backpack.
Fractions.
They're taped on my cart over there.
Fractions. Number lines. Shade.
Yeah.
Shade.
We just, what is this thing called? It's just a paper strip.
Paper strip.
Yeah. It doesn't really have a name. It's a long piece of paper. Let's see. I showed you yours yesterday. I think this is the other.
Yeah. Over here's the other classes.
That's right. All right, so let me parade theirs because I told them I would show you. I showed them yours. Have the
There's
parade
one that
going.
looks like
Okay.
it's just white.
Yeah, some colored very lightly, some colored
Dark.
a little dark. Anyway, we will hold on to these for a little while so that we can use those paper strips again in another few lessons. All right, so tape diagrams helped us. Number lines helped us. Today we're going to bring in one more visual model to help us. Even our paper strips helped us. But it says I can use metric measurement. Remember, don't worry about the measurement stuff. We'll talk about it some, but not a whole lot. and area models, that sounds familiar, to represent tenths, right here, okay, as fractions greater than 1 and decimal numbers. So again, you even see it in that. The fractions and the decimal numbers are working together. All right, so I'm going to switch to some space here to show you some things. All right, so what I want you to see today is a little bit more about fractions. I'm going to do that a bunch. A little bit more about decimals, okay? Let's say, I'm just going to borrow our tape diagrams. We're familiar with those. We know how they work. Okay, let's put the tops on our markers for right now. If I had this, and I had to explain this to second period. Let me explain this to y'all too. We were working, and somebody had a question, and it was a great question. I wish I had thought of this yesterday for y'all. But he asked, I forget exactly how he said it, but he basically wanted to know, well, what about the other denominators? Because we kept having tenths yesterday. And he's like, well, what about the other denominators, like, fourths and eighths and thirds and sixths and all those things that we saw all the time in fractions? I said, you don't have to worry about those.
Wait, so it only goes with tenths?
It's only going to be cut in tenths. Now, hold on, time out. Right now, it might be hundredths. Now, when we first hear that, we go, oh man, that's huge numbers and blah, blah. This is really not near as you think it is, okay? These work together. Think about all those times that we did multiplication or other things with multiples of 10, those numbers with the zeros on them, and it really was easier. So sometimes when you're working with these two things, especially together, it's not hard at all. Okay, and I think you'll see that. So we don't have to get working with our decimals and start wondering, what is the denominator going to be? How do I figure that out? It's pretty much right now going to be either tenths or hundredths. Okay?
Not thousands.
So, if I'm going to show you something with decimals, with a tape diagram, how many pieces do you think I'm going to cut it into?
Tenths.
10. Exactly. Okay. So, I need to double check that sometimes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm going to draw a couple of these so I can demonstrate what I need to show you. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, let's say I have some tape diagrams and let's say I have that much shaded of just one of them. I don't need the second one right now. Okay. How much do I have shaded? Let's talk about this as a fraction first. Okay. What is a fraction that would go along with just this tape diagram by itself? Yeah. 7/10, because I have 1, 2, 3, 4, 5, 6, 7 shaded, and we know there are 10 total. Okay. 7/10. That's what's doing it right there. Okay. All right. So, Alex, unfortunately, you weren't here yesterday, but I'm hoping you're gonna pick some of this up. Okay. When we have this, how is this written as a decimal? Okay. Decimals are small parts. Fractions are small parts. They're really the same kind of thing. How do we write that, Bailey? 0.7. These are exactly the same thing, okay? Also, we know we say this as 7/10, but this guy right here can be said two different ways. You can say it 0.7, and that's really kind of what we're more used to right now. But you can also say that as 7/10. Look at where the 7 is. Look at where the 7 is. Look at what place it's in. It is in this place right here, I'll make the eyes look at it. Of course, no matter how I turn those, they're going to be looking down. Gravity and all that. But those are tenths, okay? They're in the tenths place. Do you see that? They're immediately to the right of that decimal place. So these two are equal to each other. Okay, so y'all get that. We did a lot of that yesterday. What if I had this whole thing filled in? It's no longer 7/10. Okay. In decimal world, how do we write that answer? Yeah.
1.
Okay, this is 1. What's the other way to write it? Like if I'm, 1.0. And I just want you to know that those two things are the same. Okay. Somebody asked yesterday in second period, we have to put that 0 all the time? Because we were like, y'all know what we did on our boards yesterday. We were writing 0.1, 0. It does not have to be there, but I told them right now it's important because it is reminding you that something does go there or could go there. Okay, that is the tenths place, and since that's what we're working with and we're trying to get comfortable with, we want to know it's there. We want to remember it's there. Also, if you write a number like this, that 0 is to help us remember, oh yeah, that's where the whole numbers go. Okay, so that we realize where on this place value kind of chart that we are. Yeah.
If you said like there was like a hole and then more to it, would you put like, just say if you had 7 pieces after that, would you put 1?
I'm going to push pause on you right now because that's where we're heading. Okay. So hold that thought. I think we're going to answer your question in just a second. Okay. All right, so we get this. This is nothing too difficult. How about we just take that off? Okay. Now, what if we kept shading? And now we're looking at those two tape diagrams together. Okay. So we have a whole one filled in. We have part of another one filled in. I want you to, okay, hold on. I'm glad you know, but listen to how I'm saying that. We have a whole one shaded in, one whole, and we have a part of another one shaded in. Okay? What is that, or how is that going to be written as a decimal number? We also could write it as a fraction. We're going to, but what about decimals? Yeah. Yep. We have the 1 whole. And then we have 4/10. 1.4 is one way to say it. Please hear this. Or you might say it as 1 and, the word and is what you say on the decimal point. 1 and 4/10. Now when you hear that, you know exactly what to write as a fraction, don't you? 1 and 4/10. Because you're going to be asked to write numbers as decimals and as fractions. So if somebody said, here's 1.4. I want you to write it as a fraction. It's 1. And look at where that number is. It's in the tenths place. It is 4/10. So it is 4/10. Okay? It's as simple as that. 1.4, 1 and 4/10. Okay? All right, so let's practice that just a bit on your board. I'm going to give you something to write the number for. Okay, so let's shade just a little bit more. All right. So would you carefully count, because I know it's not right in front of you. Would you write the decimal number of that right there? What would that be as a decimal? What would that be as a decimal? Okay. your whole numbers. This is your, I guess we could just say parts or the leftover pieces. What you got?
1.7.
There you go. We want to make sure we say it right. Okay. He said 1.7, which I can see his board, so it looks like this. How many of you had that on your board? Okay. That is correct. Now, I want you to take that decimal number and underneath it or beside it, I want you to write it as a fraction. Think about the other way that we say it. This is 1.7. We also say it as 1 and what?
7/10.
Okay, this is not just 7/10. Okay, that's really, really different.
Got it.
Okay, I don't think you said all of, or you didn't bring this over. Okay, what you got? 1 and 7/10. Okay, so 1 and 7/10. Okay, just needing us to see these two are the same. Okay, any questions? Nothing hard about this. But doesn't that answer your question that you had a second ago? When we have something new, we want to know about it. We want to know how it works. We are naturally curious people. It's just how our brains work. Let me figure this out. And you guys are figuring it out. Sometimes you figure things out by asking questions. Okay? All right, let's just try a couple more of these. Alright, what's that number as a decimal? Go ahead and write it as a decimal and a fraction. Because you know I'm going to go there. All of those are together as one number. I might not have said that. What's the decimal number of all of that? So look, I kind of put this up here to help everybody. These are your whole numbers. These are the parts that you have. Okay. How many holes are there? And what are the pieces that you have? How many holes? Okay. How many of those tape diagrams are showing? How many tape diagrams are shaded all the way in? Two. This one is shaded all the way in, so we have one hole right here. We have one hole right here. So we have two, but that's not all we have. Okay? What do you have on the board? 2 point what? 2.7. What's the other way to say that? 2.7, or what's the other way to say it, everybody?
2 and 7/10.
2 and 7/10. Well, when I hear that, I know how to write my fraction. 2 and 7/10. You write exactly what you say. Okay? All right, so y'all see how this works. It's the whole numbers and then the pieces put together. Okay? So what if we decided to write this a little differently? Like, let's see, I need that. Yesterday, Miss Elizabeth's board would not let me shrink.
Like this is letting you shrink.
Yeah, weird. So let me just move it. I can fit what I need to fit here. Let's go. Okay. So this is another way you might see this sometime. Okay. Did we do that a few weeks ago? Or days ago? Yeah. We had 2, we added a fraction to it, or we had a whole number, we added a fraction to it, we put it together. This was super, super simple, wasn't it? It's almost just like moving furniture. You got this, you got this. Just push them together. Because that became this right here, right? Super simple. Okay. So, just like that, with our decimals, if we have this plus this, if we have 2 plus 7/10 or 0.7, what is our answer going to look like? We're just moving it together. See, that 0 is kind of holding a place for you for whole numbers. Well, the 2 is a whole number, so it gets to go there. Okay. So what is this going to look like? Yeah. 2.7. Now, I know Ishmael's up here and y'all may not can hear him, but this is easy. This is easy. This is easy. I hardly have time for him to write the problem on his board, and his hand's up, ready to answer. And I get that. But even though something's easy, you still have to hear it. You still have to learn that that's how it works. Okay? All right. Exactly. Just making sure I'm not forgetting something here. The reason I'm skipping some slides, in the original slides, they're asking you to draw centimeters and add those together and all that. It's just that measurement thing that we're kind of jumping over, so we're going to pull out what we need to know right now. Okay, let's try this for just a second. Go ahead and clear your board. Okay. All right, so if I tried or showed you unit form and I said 1 and 5/10, how would you write that as a decimal? What would that be, Will? That would be 1.5. Okay. Just trying to show you this stuff in a lot of different ways. Okay. What would it be as a fraction? I mean, this unit form becomes real easy to change to fractions. 1 and 5/10. What would it look like?
1 and 5/10.
It would look like exactly what it sounds like. Well, what do you mean 1 and 5/10? It will be 1 and then a 5 over a 10. So maybe we could say it that way. Okay. All right, let's keep going. All right, let's move to, you have a second whiteboard for a reason, okay? Don't pull your book out. Give me just a second to show you. Every now and then there's a page in here it's called a template because it's something you might use over and over again. You notice there are pages sometimes that say this page was intentionally left blank. What it means is it was left blank on purpose. Okay? No, you don't take anything out. This is page 9 in your new workbook. So we're going to tear out page 9. So if you go ahead and get that now, carefully tear it out because we're going to slide it on top of the other worksheet. That way if we ever need that other one, it's in there. You're going to pull out that template and slide it into that sleeve, that plastic sleeve. Make sure that one's on top where you can see it. No, I just said that. We're going to keep any templates we put in there, we're going to leave them in there. So don't pull the old one out. We're just going to put this one on top. This is what you want to be able to see right here. Okay. So make sure you slid it into that page protector. And if you weren't here the very first few days of school, you may not have one. I've got one for you. If I can open the package. Okay, you need to have found the page protector out of your binder. Okay, let me just slide that in here. Let's see, it's open on that. Did you get all these in your binder? Okay, when we are done, those of you that might not have had one of these, when we are done, this goes into our binder, and that's where it always stays. So that we always know. See how long it's been? It's been months since we've used this, and y'all went right to it.
Feels like forever.
Yeah. Like I said, look what's in it. It's from Place Value, which was the very first month or two that we were in school.
That's like the first day.
Now, our Target told us that we're going to use the area model, and so this way we don't have to draw it 5,000 times today. We're really not doing that many problems, I promise. But this keeps us from having to constantly draw it. We can just kind of shade it in instead. Okay? All right. So go ahead and put your workbook back, or just you can slide it in your desk. We'll use it in a little bit. Put your binder away. Okay. All right, let's go back to our chart.
Wendy,
Mm-hmm.
I ordered pizza and I have my lunch box.
You just eat what you want after Friday. Eat what you want over lunch. That's okay. All right. So did you raise your hand for lunch? Okay, that's okay. I was just making sure my numbers were right over there. All right. So you're gonna notice this centimeter ruler. Let me explain something real quick about a centimeter ruler. This might be a little hard to see because these are so used that the numbers are about worn off. Centimeters are also on the meter sticks that we used yesterday. See it a little bit better on this one. Was it yesterday? Okay. Yeah, it was. All right, remember how I told you that there was groups of 10? That's where you drew your lines, was like, at 10, then 20, then 30. Well, that 10 was a group of 10 centimeters. Okay, and then there was another group of 10 centimeters. A meter has 100 centimeters in it, so there's 10 groups of 10. Okay, that's what's nice about the metric system. The metric system's based kind of around the number 10. Well, when we're dealing with decimals, we have 10 pieces, don't we? So that's why sometimes they're using a ruler, because it works well, because it's already cut into 10 pieces. The centimeter, it's about as long as a dime. It's cut into 10 pieces, and those little itty bitties are called millimeters, and you can see them. You probably saw them up close yesterday when you were close to this thing. So our ruler's like this, all across this side. This is inches. Inches are bigger, so we're not worried about inches right now. The centimeters, well, there's more than 10. Let's see, 10 stops right there. Okay. Inside of each, these are centimeters right here. Okay. Now they only gave us like a little bit more than 5. Okay, look at me, guys. But in 1 centimeter, there are 10 millimeters. So even those centimeters are cut into 10 pieces. So here is 10 pieces, here is 10 pieces, here is 10 pieces, here's 10 pieces, and so on. It's almost like a number line that's been cut into tenths, because between every whole number, we've got 10 pieces, okay? All right, so there's our little mini measurement lesson that'll help us hopefully. How many tenths are in 1 centimeter? And then they ask about 2 centimeters. Okay, I just told you, every centimeter has how many pieces?
5.
That's why you need to stay with me. I need your eyes, I need your ears. No, every one of these, let's get a pen here. This is 10 pieces. They're little bitty, but they're millimeters. This has 10, This has 10. This has 10. This has 10. They're just tiny. Okay? So how many tenths are in 1 centimeter? If I grab one of these, I'm going to do it on the bottom. How many tenths are there? Yeah. There's 10 tenths. Okay. So how many tenths are in 1 centimeter? 10. How many are in 2 centimeters? 20. You're just counting by tenths. Okay, but here's the question they're really trying to get you to. How many tenths are in 2 6/10 centimeters? Every time you have a whole number, you have 10 tenths. Like fractions. Every time you have a whole number, you have 10 tenths. So if we have 2 6/10, how many tenths is that all together? Every one of these has 10, and then you've got these extras. Every whole number has 10, and then these are your extras. So how many times are we going to have 10, everybody? 2. What's 2 times 10?
20. So it's going to be
20 right here, and then the extras. 20 plus 6 is?
26.
Okay. All right, let me show you what this looks like here. Oh, well, they say write it in fraction form. What is this going to look like in fraction form? Can you describe it to me? Because I know you're going to want to say, well, 2 6/10. What does that look like? Yeah.
It's 2 and then 6 and then under that would be 10.
Yeah. Now, what do you think that area model is sitting there waiting for us to do?
To draw.
Not draw.
I mean to shade.
Okay. How are we going to make this look like these?
By shading on to and
How many pieces do you think these are cut in?
tens.
10. 10 is a very big deal number in decimals. Yeah?
Shade 2 holes up. Shade 2 all of them and then shade 6 on one of them. Dang, 10 times.
Yeah. All right, and then 6, I'm just going to go bzz, 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 bzz. Actually, I'm going to go 1, 2, 3, 4, 5, 6. I'm going to draw a box around 6. Okay. 2 6/10. So that's what it looks like on the area model. Okay. So we're going to do some of these. I just wanted to see what, for you to see it first. Okay. So let's take this one. Okay. 2 7/10. Now before we start shading anything, right beside it, because I just want us to get used to seeing this both ways. Right beside it, write the decimal form. What does this look like as a decimal? Valerie, what's it going to look like? What is this? Yep. Okay. So there's our 2 ways of writing it. Now, how are we going to shade that in? Brandon, what are we going to shade in? How many whole?
2 holes and 7 of another.
Exactly. All right, so let's do that. And see, you already have the boxes drawn. So, guys, just do the kind of outline it. Maybe trace around it and then kind of, that quick shading. And then go around 7 of them over here. Now, we got to get very familiar with 10. Do I have to sit there and go 1, 2, 3, 4, 5 all the way to 7? I could, or I could just go leave 3 empty. We know the combinations that make up the number 10, and we're going to get real familiar with that. Okay. So the area model is just simply one other way to see the decimal, or actually the fraction too, but especially the decimal since that's what we're focused on. Okay? All right, so y'all see how this works. Don't let this take you a long time to shade these. Okay? Because we're going to do that. Oof. Okay, let's try another one. First, write it as a decimal, then shade it in. So this time we've got 3 2/10. Alright, sometimes you gotta be careful that the plastic doesn't move on these little whiteboards. Alright, what does it look like when it's a decimal? What does the decimal number look like? 3.2. Okay. What did we shade in? How many whole boxes did you shade in?
3.
3 whole boxes, and how many pieces of another box did you shade in?
Got it.
Because this is 3.2. So we need 3 whole boxes shaded in. And how many pieces of another box? 2. So if you didn't do those 2 pieces, make sure you do that. So you needed 3 whole boxes. And then 2 of these strips on another one. Okay? Make sure we see why we're doing it. Okay? All right. So this isn't so bad. Let's do just 1 or 2 more. We're done. You know, not so bad. Now, what's different about this? Yeah. It's an improper fraction. How can we make it even easier, though? Again, I'm hearing the word easy up here in front of me. Maybe it is to you, but I want to know how to make this super simple. Okay? What could we do at first before we ever start shading anything to make this easier? Okay, so go ahead. If you turn that into a mixed number, then you're going to see how many holes you're going to have and how many pieces you're going to have. So let's do a number bond. Now, come on. 10 may look big, but it's easy to work with. How many 10s are in 31?
30.
3. Yeah.
30.
Yeah, not 30. That would take us to 300. All right. But it is like this. That is how we write it, and that's probably what you were thinking. Okay. That is 3. And then 1 left over. So now we have the number, let's leave, stop it there. 3 1/10. Okay, I want you to write that as a decimal also. What does 3 1/10 look like as a decimal? Jayla, what's it going to be? 3.1. Good. Okay. Now, is that easy to color in or to shade in?
Yes.
Most definitely. And you might have seen that before. You might have, guess what? You could have sat there and counted 31 of these. It would have taken a little while, but if you know these are 10s, 10, 20, 30, and then 1 more. Okay? So, the more we work with the number 10, the more we work with these things, the easier they're going to be.
For some reason, it looks like it's shaped in hundreds.
Mm-hmm.
Yeah.
These look like hundreds.
Yeah.
You know why? We're used to seeing that grid that has lines this way and this way, and it's like 100 square. We're going to later on, so I know you miss it, but we'll get there.
This is so easy.
What?
This is so first grade
Okay.
stuff.
We need it to feel easy right now to understand it really well.
I can do
Okay.
this almost.
Miss Terry, I know I mentioned her a lot, but she comes into our room in the second period, and she also shares a lot of stuff with us. And she said, guys, I've been doing decimals with the 5th graders. and she said, you know, you do a little bit, not super hard, but a little bit harder stuff in 5th grade, and so now, you know, we want it to feel pretty easy and comfortable, so that when we get there, we're ready to go. Okay? Yeah.
I keep on forgetting that you don't have to worry about the denominator. So anytime I'm answering a problem, I keep on thinking that I have to do something with it.
Mm-hmm.
With the denominator.
We do. It's just that habit we got into with fractions. Okay. Go ahead and try to do this one on your own. This is our last practice right here. Go ahead and write it as a decimal also, and shade in. Okay. You may be seeing this without having to do the number bond. A lot of folks will get to that point. If you need that number bond, absolutely make it. Okay. How many sets of 10 can we pull out of that? How many? 2. With 6 left over. Okay. So what does our fraction look like? What does the mixed number look like? Let me ask that first. 2 6/10. What does the decimal look like?
2.6.
2.6. And then when you shaded, how much did you shade? Brandon, how much did you shade?
You shaded. I shaded 2/10 and 6 more of the other one.
Okay, so 2 whole boxes.
Yes.
Okay, so and then 6 of another. 1, 2, 3, 4, 5, 6. There we go. Okay. There you go.
Can we do one more?
No. All right, so we will, but it'll be on our problem set. All right, so this is the thing. Don't be lazy about putting this other whiteboard away. You knew where it was immediately today because you had not been lazy long ago. So go ahead and snap that, clean it off, snap it back into your binder, and then go ahead and put your other whiteboard away, marker, all that, okay?
This Wendy,
Yep.
I don't know why, but when you said whiteboard,
Mm-hmm.
I thought you were talking about the yellow one. This one.
A yellow one?
This one. The one.
Oh. You know what?
Yeah.
Since we're moving and putting away into that, can you find that? It should be in your desk. And let's make a stack over. You see that empty spot over there? Yeah, I really thought we would use those at the beginning, and we still might at the end. I may pull those out, but I know it has, and I appreciate y'all taking care of them.